It starts with a single drop of melting ice, but gravity takes hold, and that drop instantly accelerates, combining with millions of others to carve a rushing mountain stream. Every river belongs to a larger drainage basin, a geographic funnel spanning hundreds of miles. This network gathers water from a high-elevation source and guides it all down to a low-elevation sink, like a lake or an ocean. Along the journey, tributaries feed into the main river. Nearing its end, it splits into distributaries, branching widely before emptying. Zoom out to India. This landmass is supported by 12 major river basins, each spanning over 20,000 square kilometers. To understand how 1 billion people survive and how their agriculture and economy actually function, you have to follow this massive water network, tracking it from the freezing peaks of the north down to the tropical southern oceans. The journey begins high in the Himalayas. Rivers born in these extreme altitudes are perennial, flowing year-round because they are constantly fed by the deep glacial ice and heavy snowpacks locked atop these jagged peaks. One of the most vital paths begins in Tibet. The Indus River cuts a brutal westward path through high-altitude mountain deserts. It forces its way through the barren, rocky valleys of Ladakh before eventually spilling out into the flat plains of Punjab. Moving east, you find the Ganga. Flowing south and east, this river gathers water from multiple glaciers to sustain an incredible population density. The riverbanks are packed with ancient cities and massive agricultural hubs that depend entirely on its steady flow. Entering India from the northeast is the Brahmaputra. This system carries an extreme volume of water. By the time it reaches the plains of Assam, it swells so wide it looks more like an inland sea, requiring massive bridges. The immense, predictable volume of these 3 mountain rivers allows for serious engineering. Deep in the steep green valleys, concrete dams harness the rushing water to generate hydroelectric power and control irrigation for crops downstream. Without this reliable supply of glacial meltwater, the dense civilization and sprawling agricultural delts of North India simply could not exist. Travel south to the Peninsular Plateau, where the water system shifts. These rivers lack glaciers, relying instead on seasonal monsoon rains soaking into the lush hills of the Western Ghats. Southern India tilts downward to the east coast. Gravity drives rivers like the Godavari, Krishna, and Kaveri eastward into the Bay of Bengal. But the Narmada and Tapi flow west into the Arabian Sea, trapped inside deep rift valleys that force the water backwards. Because these peninsular rivers rely heavily on seasonal rain, their water levels fluctuate. Managing them requires massive dams designed to trap the monsoon surge and hold it for the long, dry months ahead. Then there is the Luni River, an outlier that never reaches an ocean at all. Part of a closed drainage system, it flows into the harsh salt flats of Gujarat and simply evaporates into the cracked earth. This seasonal, terrain-locked flow forces southern and central India to manage water and agriculture based on monsoon cycles rather than steady glacial melt. Eventually, nearly all of these immense water arteries reach their final sink, spilling into the Arabian Sea to the west or the Bay of Bengal to the east. Where they meet the ocean, the rivers slow down and drop millions of tons of sediment. The Ganga and Brahmaputra merge to form the Sundarbans, a massive, incredibly fertile delta where tranquil waterways cut seamlessly through dense mangrove forests at the ocean's edge. But how much water actually makes it to the coast is heavily regulated. Before emptying out, the precise volume flowing through many of these rivers is strictly divided by international treaties between India and its neighbors. And once the water spills into the sea, the cycle immediately restarts. The ocean surface heats up, water evaporates, and thick monsoon clouds form and blow inland, ready to drop their rain and snow on the mountains to start the descent all over again. These rivers are a single, continuous, circulating engine of water, an engine that dictates the survival, the economy, and the future of the entire subcontinent.